Hi, hello, welcome to Homeschool. This is your class 10 Mathematics NCERT or CBSE board. Both the boards are same. Whereas only tiny differences, textbook cover page is different and whereas the numbering of the chapters is different. Remaining everything is same. I hope everybody are safe at your home. Don't worry about mathematics and science. This year we are there with you. Follow your journey of class 10 mathematics and science along with the homeschool. Hearty welcome you all to the class 10. Mathematics is very easy when we understand the concept. Each and every problem is covered in the channel. Keep a goal, try for the goal, and definitely you're going to achieve your success. Okay, so what we need to do every day? Whatever you watch in the video, try to practice on that day itself, and after completing every exercise, go back to the first problem onwards and complete full exercise. Then after completing chapter, once you just have a review of complete chapter, then you will be perfect about the chapter. So nothing is difficult in mathematics. Today is an introduction session of arithmetic progressions. Arithmetic progression is very easy. But if we know formulas, we can do anything in this chapter. If we don't know formulas, it will be difficult for us. So this session, we are going to discuss only about the formulas and introduction part of this chapter. Let's begin. Arithmetic progressions. It is your chapter number 1. What do I mean by arithmetic progressions? Arithmetic. It is one branch of mathematics and it is about the study of numbers using various operations. Various operations means in arithmetic we can see addition, multiplication, subtraction and division operations. Arithmetics, it is a branch of mathematics. It deals with the study of numbers using various operations like addition, subtraction, multiplication and division. Then coming to progression. Progression is a list of numbers. We have different types of progressions. Arithmetic progression, geometric progression, harmonic progression. But in this class 10, we are going to deal only with arithmetic progressions. Before starting this definition, let me go back to another statement. First, we should know about a sequence. What is a sequence? It is an orderly arrangement of numbers. It may be any numbers. Arrangement of numbers by a definite rule. Just let us see the numbers where they are following any rule. Let's check it out. I have written some examples. First one, 5, 10, 15. What is the rule behind this? Yes, 5, if we add 5, we get 10. 10, again if you add 5, 15. Then what will be these three places? Can you guess? 15 plus 5, 20, 20 plus 5, 25, 25 plus 5, it will be 30. Yes, this is a sequence. It is arranged in an order. What is the rule behind the sequence? That is adding 5 for every number. Let us see the next one. 2, 4, 6. 2 plus 2, 4. 4 plus 2, 6. Then what will be the next 3 gaps here? 6. 6 plus 2 will be 8. 8 plus 2, 10. 10 plus 2, 12. Sequence. The numbers are arranged in a proper order by a definite rule. And you can see the commas between the numbers. Let us see the third example. 3, 5. How can we get 5? 3 plus 2 is 5. 5 plus 2, 7. 7 plus 2, 9. 9 plus 2, 11. What will be the next numbers? 13, 15. Like this, you can guess the next numbers. But I have written here, so on. So on means where it ends, we don't know. The sequence is never ending. Okay, what is the rule behind this? What is the rule? Adding 2 for every number. See the next example. 6, 1. 6, 1. I think here subtracted. How to get 1? In 6, 5 is subtracted. And again look here. 1 minus 5. 1 minus 5 will be minus 4. Again for minus 4, subtract 5. Minus 9. Minus 9 minus 5 will be minus 14. What is the rule behind the sequence? Subtracting 5 for every number. Similarly, you can write here adding 5, adding 2. These are all the sequence followed by a definite rule. Let's see the next example. Root 2, root 8, root 18, root 32, so on. So observe here carefully. It is in surd form. By seeing this example, everyone will say it is not a sequence. No, we need to simplify the surd into its simplest form. And then we need to observe. Root 2, can you simplify? No, further we cannot simplify. So let me write again here, root 2. Root 8, can you simplify? Yes, root 8 can be written as, is 8 a multiple of perfect square? Yes, 4 2s are 8. And again you can write this as root 4 into root 2. Root 4 value will be 2, root 2. Like this we need to simplify root 8. And write here 2 root 2. Next one, root 18. Root 18 also same manner. Root 18, how can you write this? Is root 18 a multiple of perfect square? Yes. Which one? 9 2s are 18. Write this as 9 into 2. Split this root. Root 9 into root 2. Root 9 is nothing but 3. 3 root 2. Right beside this. Similarly, see the next one. Root 32. Check root 32. Is it a multiple of any perfect square? Yes. 16 2s are 32. Root 32 can be written as root of 16 into 2. Split the root. Root 16 into root 2. Root 16 value is 4 root 2. Write it here 4 root 2 so on. Now observe here root 2, 2 root 2, 3 root 2, 4 root 2. Can you guess next numbers? Yes. 5 root 2, 6 root 2, 7 root 2, 8 root 2, 9 root 2. Now try to say the rule behind this. Look here, root 2. Next one is 2 root 2. How do you get 2 root 2? For 1 root 2, if you add another root 2, it will be 2 root 2. For 2 root 2, again if you add one more root 2, it will be 3 root 2. So try to understand here carefully. Root 2 plus root 2. So in these two, root 2 is common. Take surd this side. 1 plus 1. That will be 2 root 2. Okay. The next number. How do you get next number? For this, again if you add root 2. Just check it out. Again in these two, root 2 is common. Take out common. 2 plus 1. 2 plus 1 will be 3 root 2. Okay. So what is the rule behind the sequence? Adding root 2. Adding root 2 for every number. And see the last example here. 3 plus root 2. 3 plus 2 root 2. 3 plus 3 root 2. 3 plus 4 root 2. What will be the next number? 3 plus 5 root 2. 3 plus 6 root 2, 3 plus 7 root 2. Here what is the rule? For every number, root 2 is added to get the next number. Okay. So now observe here. These are all the examples for sequence. Then what about the numbers which are not a sequence? Let us see those examples also. Let us go with the examples which are not a sequence. 1, 5, 6, 10. Observe here, what is the rule behind this? 1 and 5. Okay, for 1 if we add 4, we get 5. But next number, adding 1. Is the sequence is following with the same rule? No. Here adding 4 and here adding 1, adding 4. So therefore, what I can say? Therefore, this is not a sequence. This is not a sequence. Why it is not a sequence? The arrangement of numbers are not following a definite rule. Therefore, it is not a sequence. If you want, you can go with another number. Let me take 0, 7, 3, 2. Observe here, numbers I have arranged. But is this a sequence? No, 0 increased, again decreased. It is not a sequence. Therefore, these two are examples for not a sequence. First, if any numbers given for you, observe it is a sequence or not a sequence. Now, the next point we are going to learn is, say here 5, 10, 15, 20, 25, 30. We are saying that the numbers are arranged in a sequence and these numbers we call them as terms. Terms we call it as A1 first term, second term A2, third term A3, fourth term A4, fifth term A5, sixth term A6, so on. Where it ends we don't know. So up to AN. The numbering of sequence is given by using term. A1 first term, second term, third term, fourth term, fifth term, sixth term. How can we call this? A1, A2, A3, A4, A5. Okay. Now we are going to learn next concept is finite sequence and infinite sequence. What is a finite sequence, children? Finite sequence, the sequence having finite number of terms. Finite number of terms means what? There is an ending for the sequence. So look here, 1, 2, 3, 4, 5, 6 terms are there here. Therefore, how many terms are there? 6 terms are there. There is a finite number of terms. Sequence having a finite number of terms. Having a finite number of terms. That means finite, countable. I can count and say how many terms are there in the sequence. So let's start counting. 1, 2, 3, 4, 5, 6. In the sequence, there are 6 terms. Okay, it is a finite sequence and there is an end for the sequence. Look here, next one, 2, 4, 6, 8, 10, 12. This is also a countable sequence. That means it is a finite sequence where there is an end. And next example, 3, 5, 7, 9, 11, so on. Is it ending? Where it ends, do you know? Don't know. So, the sequence having infinite number of terms is called as infinite sequence. Infinite number of terms. How many terms are there? We don't know. So, infinite number of terms, we call it as a infinite sequence. In easy manner, where the sequence have an ending, finite. Where there is no ending, infinite. Suppose, if any sequence you have like this, 100 you have here. If any sequence you have last number like this, is it a finite sequence or infinite sequence? It is finite sequence. Middle numbers you don't know, but you know the last number. Where the sequence ends, you know. Therefore, this is a finite sequence. And observe here, is it a finite? No, not a finite. It is infinite sequence. And this is finite sequence. Come to the next example. So on, dot 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 indicates where it ends, we don't know. Therefore, this sequence is a infinite sequence. And the last example also, infinite sequence. After finite sequence, you can write the examples, children, this, and this example. For infinite sequence definition, sequence having a infinite number of terms is called as infinite sequence. For this, what are all the examples you are going to take for this? You can take this one, you can take this, and you can take this. Okay, so like this, you should understand carefully what is a sequence and what is a finite sequence and what is an infinite sequence. Arithmetic progression. Arithmetic progression can be written in short form as AP. Now let's see the actual definition of arithmetic progression. It is a list of numbers in which each term is obtained by adding a fixed number to the preceding term, except the first term. What do you mean by this definition? So let me take first term as A. Okay, so each term is obtained by adding a fixed term to the preceding term. Do you know what is preceding and succeeding? Preceding before number, succeeding after number. Okay, so this is preceding number. For this preceding number, if you add a fixed number, let the fixed number I take it as small d, we get the next term. Then what about the next term? Again, for the preceding term, understand the concept here. For the preceding term, if you add fixed number, what is a fixed number I am saying? D is the fixed number. Then, in order to obtain the next term, for the preceding term, add the fixed number. So, what is the preceding term? A plus D. For this, add one more D. What happens? You can rewrite this as A plus 2D. D plus D will be 2D. Same manner, A plus D, A plus 2D. And in order to obtain next term, for this, you add fixed number. What is this set? A plus 2D, no? Again for this, add one more D. This is a fixed number. Each term is obtained by adding a fixed number to the preceding term. That means 2D plus D will be 3D. So the next term is A plus 3D. Like this, we can get the terms. Okay. So this is first term and this is second term and this will be third term. This will be fourth term. Observe here carefully. I have taken first term as A. We call this as first term. First term is A. And what do we call this fixed number? Fixed number is known as common difference. We call the fixed number as common difference and it is denoted by the letter small d. So next term, what it will be? A plus 4d, A plus 5d, so on up to last term, what it will be? Can you guess it? Yes, we can guess. Look here. A1, there is no d. A2, 1d there. Okay. A3, 2d you have. A4, 3d you have. Suppose if I see last term maybe an, then what it will be? Every term is followed with the first term. A plus, here 4 means one number reduced, 3D you have. Same manner, n minus 1 into d. Okay, so what is this line called as? General form of AP. General form of arithmetic progression is this one. A plus D, A plus 2D, A plus 3D, so on up to A plus n minus 1 into D. So let us read the statement again. Arithmetic progression. It is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. What is this except the first term? First term is obtained as it is, and we are not going to talk about first term. And the second term onwards, how it gets? For the first term, if we add a fixed number, we get the second term except the first term. It is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Okay, and what is the general form of arithmetic progression? A plus D, A plus 2D, A plus 3D, so on up to A plus n minus 1 into D. How do we see the term numbering? First term, second term, third term, fourth term. That means A1, A2, A3, A4, so on up to AN. Okay, this is numbering and this is a general form. And one more important point, last term. See this? We may write this as AN is equal to A plus n minus 1 into D, and we call this as general term. This is general form. General form means you need to write all this, and if they ask you what is the general term of arithmetic progression, you need to write A plus n minus 1 into D, or you follow with AN is equal to A plus n minus 1 into D, where A is a first term, N is a number of the term, D is the common difference. Okay, let us see one example for arithmetic progression. Example, let me take 2, 4, 6, 8, 10, so on. 2, 4, 6, 8, 10, so on. It is an orderly arrangement of numbers by a definite rule. What is the rule? Adding 2 for every number. Adding 2 for every number except the first term. Okay, so now is this arithmetic progression? Yes. Every number is added by a fixed number. What is that fixed number? 2. 2 is the fixed number. So that is called as a common difference. So what is the first term? A. A is called as the first term. A value is 2. Okay. A, I can say that A1 is equal to A, I can say, or I can say this as first term is equal to A1 or A that is equal to 2. Any way we can call this. Okay. So every number is obtained by adding a fixed number. What is that fixed number? Let us find out. Let us see here. A1, A2, A3, A4, A5. We need to find. Okay. So let the fixed number is represented by common difference D. We know it is 2, but there is a rule for it. Common difference D is equal to every number A2. Before term you subtract. A2 minus A1, 4 minus 2, it is 2. Okay. And let us see the next pair. A3 minus A2. See, we are talking here, every term is obtained by adding a fixed number. In order to find that fixed number, we need to subtract the preceding term in succeeding term. Okay, So A2 minus A1. 4 minus 2 will be 2. And next pair, A3 minus A2. That is 6 minus 4. That will be 2. And next pair, A4 minus A3. 8 minus 6. That is also 2. And go with another pair. A5 minus A4. 10 minus 8. So look here. All you get the same answer. Every number is obtained by adding a fixed number. Okay. How to find that fixed number? What do we call that fixed number? Called as common difference, and it is denoted by the letter small d. Okay. In order to find the common difference, we go with the rule of subtracting. A2 minus A1, A3 minus A2, A4 minus A3, A5 minus A4. Suppose if all the difference are having same number and the difference is constant. Constant in the sense same answer if you get, then this sequence is in arithmetic sequence. Okay, you may say this as arithmetic sequence or arithmetic progression. The sequence is in arithmetic progression. Suppose if any one of the difference is not same, then you can say that it is not in arithmetic progression. Let's take another example. 2 5 by 2, 3 7 by 2, so on. Check whether it is an arithmetic progression or not. Okay, how to check? Let us check. See here, first number the sequence. A1, A2, A3, A4. Okay, we know only 4 terms. First term is called as A or A1. Second term A2, third term A3, fourth term is A4. So look here carefully. What is the common difference? How to find out? A2 minus A1. What is A2 value? 5 by 2 minus A1 value is 2. Now we need to do LCM. Do LCM. 2, 5 minus 4. 5 minus 4 will be 1 by 2. Okay. Now this one next. Again next pair. We need to check all the pairs. Don't do only one pair and say it is arithmetic progression. We need to check at least 2 to 3 pairs. D is equal to A3 minus A2. A3 minus A2. A3 value is 3 minus A2 value is 5 by 2. Okay, again do LCM. 3 2s are 6 minus 5 whole divided by 2. That will be 1 by 2. And go with another pair. We have another, that is D is equal to A4 minus A3. A4 value is 7 by 2. A3 value is 3. Do LCM. 2, 7 minus 3 2s are 6. 7 minus 6 is 1 and 1 by 2. So what you can see? See here, the common difference between the pair of terms is constant. If the common difference is constant, then you can say the sequence is in arithmetic progression. Okay, try to identify carefully. First term is A and the common difference D value is 1 by 2. If you know A and D, any term you can find in the arithmetic progression. Okay, is this clear? Let's have a recap of this board. Arithmetic progression. It is a list of numbers in which each term is obtained by adding a fixed number to the preceding term, except the first term. What is the general form of arithmetic progression? A plus D, A plus 2D, A plus 3D, A plus 4D, so on up to A plus n minus 1 into D. And how do we number the terms? First term, second term, third term, A1, A2, A3, so on up to An. N is the number of the term. Okay, suppose you have 10 terms. 10th term. Okay, what we are saying? 10th term. N is a term number. and an is a term value. Okay, n is the number of the term and an is the value. General term, last term we call it as a general term, and we may say this as L. Last term we say it as an or L. Okay, so first term is A, common difference is represented by small d. Last term an or L, n is the number of the term, an is the term value. A is the first term, D is a common difference, n is a term number, an is nth term. And make sure that you should remember the common difference may be positive or negative, or it might be equal to 0. Common difference may be positive value or a negative value or 0. What is nth term formula in arithmetic progression? An is equal to a plus n minus 1 into d. This is very important formula in arithmetic progression. Suppose, let me take one example. If a is equal to 2, d is equal to 3. If a is equal to 2, d is equal to 3. Find 10th term. Observe here, 10th term. 10th term means A10. Yes, 10th term A10. 8th term A8. 5th term A5. Like that you need to remember. Find A10. What is the formula we know? An is equal to a plus n minus 1 into d. And which term we need? 10th term. So n value is 10. A value 2. N value is 10 minus 1. D value is 3. 2. 10 minus 1 will be 9. 9 into 3. 2 plus 9 threes are 27. 27 plus 2 will be 29. Therefore, 10th term A10 is equal to 29. Like this, if you know first term and common difference, any term you can calculate. Okay. Now, nth term an, and you can say this is also equal to L. Last term, nth term, last term. Nth term in the sense we don't know what is that last term. And last term is also represented by L. Suppose if you know A means what? First term and common difference, you can apply this formula. Suppose if you know last term in the sense an value. Last term is known, suppose it might be 10. Okay, and common difference is 1. Find the sixth term. Find the sixth term. That means A6 is equal to how much? So which formula you are going to take? I don't have A. From first to if you add, you are going to take A plus n minus 1 into D. And the question is, from last of the sequence and from backward you say sixth term. Backward sixth term, how can I find? What is the formula? There you can use an is equal to last term. Here first term plus you have done. But here last term minus n minus 1 into d. This is also formula which we need to remember. Okay, if you need to find any number from last term and common difference given, this is a formula. So let us find out. A6 is equal to L value is 10 minus n value is 6, and this is n value. 6 minus 1 into d value is 1. 10 minus 6 minus 1 will be 5. 5 into 1, 5. 10 minus 5 will be 5. 5 is your answer. Therefore, sixth term is 5. Okay, let us check it out this one. I have taken last term is 10 and common difference is 1. Common difference 1 means every number is obtained by adding 1. but I am coming backward. Last number known. I don't know these numbers. So if you want front numbers, you will add common difference. And if you want back numbers, you are going to subtract the common difference. See here 10. 10 minus D, 9. And 9 minus 1, it will be 8, 7, 6, 5. Let's check it out. First term, second term, third term. From last we are saying, right? From last term we are saying means this is the first term, second term, third term, fourth term, fifth term, sixth term. Yes, from last A6 is 5. Okay, so don't be confused. When from first term onwards given, this is a formula. Suppose if any question, if they ask you from last term find fifth term means use the formula AN is equal to L minus N minus 1 into D. There is no confusion. Asking this type of question is very rare. Most of the questions we solve by using this formula. Okay. Next concept is series. What is series? Sum of the sequence is called as the series. Series. Series is represented by the letter S. Let me take a sequence 1, 3, 5, 7, 9. I am talking about series. Sum of the sequence is called as a series and it is represented by the letter S. So look here, sum of the sequence. Sum, add 1 plus 3 plus 5 plus 7 plus 9. I am adding. Sum of the sequence, we call it as a series and it is represented by the letter S. So now, whereas we number the terms as A1, A2, A3, A4, A5. Now, when I talk with the series, I say this one as S1. First term or sum of one term is first term only. Suppose if I add A1 plus A2, how many terms you are summing up? 2 terms. A1 plus A2. That means S2. If I add 3 terms, S3. Like this you should remember. So look here, series is represented by the letter S. S1 is nothing but A1, that is 1. S2. S2 is nothing but sum of 2 terms. Sum of 2 terms starting from first term and second term. A1 plus A2 is equal to 1 plus 3. That will be 4. S2 value is 4. Similarly, S3. Sum of 3 terms. A1 plus A2 plus A3. That is 1 plus 3 plus 5 will be 9. S3 is equal to 9. Same manner, you can continue S4, S5. And you need to remember one formula here. That is AN is equal to SN minus SN minus 1. AN is equal to SN minus SN minus 1. You need to remember this formula, children. Let us take one example and we'll understand. Suppose N value I will take 2. A2 is equal to N value 2, right? I will substitute here also 2. S2 minus S2 minus 1. It will be 1. A2 is equal to S2 minus S1. How it will be? Look here. S2 is nothing but A1 plus A2. Okay. If I know A1 is nothing but S1. So, look here. S2 is nothing but A1 plus A2. A1 is also said as S1. Send this S1 other side. S2 minus S1 is equal to A2. This is only the formula. Okay. Any term if you want, any nth term if you want, and if you know Sn and Sn minus 1, you can directly subtract and say that term. Let's take one example. S3 is equal to 9, S2 is equal to 4, A3 is equal to question mark. So, like this, if you have, use this formula. N value is 3, right? A3 is equal to Sn S3 minus 3 minus 1 will be 2. That is S3 minus S2. What is S3 given? 9. S2 value is 4. 9 minus 4 will be 5. Therefore, A3 is equal to 5. Just check it out. Is A3 5? Yes. I have taken this example only. Like this, any question if asked, this is the way you need to go. And what is the formula you need to remember? An is equal to Sn minus S of n minus 1. And now, very important formula we are going to remember. That is sum of n terms. Sum of n terms in arithmetic progression. Sum of n terms in arithmetic progression. That means you need to sum. How many terms you need to sum? We don't know. Like this, suppose if I take a series like this. Let me take this example. 1 plus 3 plus 5 plus 9 plus so on. I don't know where it ends. It is an infinite series. Infinite series. Where it ends, we don't know. But I need to add all these numbers. So what is the formula behind this? We need to remember the formula. Sn is equal to sum of n terms. How do we say? Sum of n terms. Sn is equal to n by 2 into 2a plus n minus 1 into d. Sum of n terms in an arithmetic progression. Formula is this one. Try to remember. Sn is equal to n by 2 into 2a plus n minus 1 into d. Where n is a term number, a is a first term, d is a common difference. Let us take this example and find Sn. Let me take here 1 plus 3 plus 5 plus 7 plus 9 so on. Find Sn. Find Sn is equal to question mark. By observing this, we need to first find what is the first term and common difference. Okay. First term a is equal to a1 is equal to 1. First term a1 or a that is equal to 1. And now common difference. How do we get the common difference? A2 minus a1 will give you the common difference. A2 is 3, a1 is 1. 3 minus 1 will be 2. Common difference d is equal to 2. Let us find sum of n terms. Rewrite the formula. Sn is equal to n by 2 into 2a plus n minus 1 into d. Sn, n value we don't know as it is. I will write n by 2 into a value is 1. 2 into 1 plus n value as it is n minus 1 into d value is 2. N by 2 into 2 into 1 2 plus n into 2 2n and here plus into minus 2 into 1 will be 2. Minus 2 plus 2 will be cancelled and directly don't cancel this. Try to multiply 2 n into n square by 2. Now cancel this 2 and that will be sum of n terms Sn is equal to n square is your answer. This is for infinite series. Suppose if they give infinite series and if they ask you sum of 10 terms enough for me. Sum of 10 terms. 10 terms means I need to calculate S10. Okay. Same formula. N value you need to take 10. Substitute in n place 10. 10 by 2 into 2 into 1 plus 10 minus 1 will be 9 into 2. 10 by 2 will be 5. 5 into 2 into 1 2. 9 2s are 18. 18 plus 2 will be 20. 25s are 100. So sum of 10 terms in the given arithmetic progression is 100. If you know a, d and n value given, sum of any number of terms you can find. Okay, is this clear? So same manner you can find S20, S30, S5, S6 direct by using formula. Okay, there is one more formula. Sum of n terms when the last term is not given. Observe here carefully. Sum of n terms when the last term is not known for you. Suppose a last term is known for you. It might be 99. When last term is known, there is one more formula you need to remember. That is Sn is equal to n by 2 into a plus l. It is very simple. When last term, I call this number as an or l. Okay, so use this formula. This formula is also important. Sn is equal to n by 2 into a plus l. And same formula, you can rewrite it as Sn is equal to n by 2 into a plus an also you can write. Sn is equal to n by 2 into a plus an or n by 2 into a plus l. When last term is given, you can use this formula or this formula. Okay, you can apply any of the formula, but this formula is very easy when last term is known. And which term is this 99? First we should calculate which term is this. Which term is this means what is this one? an. An is equal to 99. Again we need to apply an formula. An is equal to a plus n minus 1 into d. Observe here a value is 1, n value is don't know, n minus 1, d value is 2, an value is 99. Okay, now this one 99 is equal to 1 plus 2n minus 2. Okay, 99 is equal to 1 minus 2 will be minus 1, 2n minus 1, and this minus 1 send other side. 99 plus 1 will be 100. At a time you can interchange. 2n is equal to 100, n is equal to 100 by 2. That will be 50. So what is this n value then? N value is 50. 50 is what? This is 50th term is 99. First we should find n value. Which term is that last term? 50. So now S 50 terms is equal to 50 by 2 into a plus l, that is 1 plus 99. Let's find out this one. Last term is 50. Sum of 50 terms I need to find. Therefore, n by 2, 50 by 2 into a value is 1, l value last term is 99. 50 by 2 will be 25. Few cancel, 25. 99 plus 1 will be 100. 25 into 100 will be 2500. Therefore, sum of 50 terms is 2500. No need of adding 1 by 1. 1 plus 3 plus 5 plus 7. Like this, no need. Okay. Sum of the numbers in arithmetic progression. Calculation is very easy. Use this formula or that formula. Your choice. When last term is given, you can use this also, you will get the answer. You can use this formula, you will get the answer, or that formula. Okay. When last term is not known, you cannot apply that formula. You need to do only by using this formula. See the last concept in this chapter. You will be having one 4 marks question compulsory from this chapter, and that question will be in this form. That is sum of 3 numbers, sum of 4 numbers, or sum of 5 numbers is 5 times more than, less than. They will ask like this. Okay, first, if nothing is given, if they say sum of 3 numbers, which 3 numbers we need to take? There you should think a little. Look here, suppose, what is the general form of AP? A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D, A plus 6D. Let me stop. If you want next term, common difference is added. Then if you want before term, what you do? Common difference is subtracted. What will be before term? A minus D. And this term if you need, again subtract D. That will be A minus 2D. A minus 3D. Again A minus 4D. A minus 5D. A minus 6D. Like this. So on. And this side also. So on. Okay. Try to understand here. First term A1, second term A2, we know. But some type of questions, they will ask you sum of three terms. Suppose if you get any problem, sum of three terms and product of three terms, if they talk, don't go with the three terms A plus D, A plus 2D, don't go. You just take sum of three terms. If given, what are the three terms you need to select? Go with these three. Why these three terms? If you add, D will be eliminated. Why? Minus D plus D will be cancelled. Okay. So if any word came in the problem, sum of three terms. Let the three terms be A minus D, A plus D you can take. Same manner, if any 5 terms asked, sum of 5 terms given. Sum of 5 terms given. So which are the 5 terms you need to take? Make sure A should be middle. 1, 2, 3, 4, 5. So take the 5 terms as A minus 2D, A minus 2D, A minus D, A plus D, A plus 2D. So these are the 5 terms you need to assume in the problem. If you add all these, what happens? Minus D plus D, minus 2D plus 2D will be cancelled. Then the word comes, what about 4 terms? Suppose if they give you in the problem about 4 terms. 4 terms, how can I take? Suppose if I take A, these two and this one if I take, 2D will be left. D is not cancelled. And make sure whatever the general form you take, that general form should be in arithmetic progression. Okay. So 4 terms, when the word 4 terms come, just imagine here, you leave this one. Leave this one and again leave this one. See, I just skip every middle term. I try to skip the middle term such that they will be in arithmetic progression. 4 terms. So which are the 4 terms I am going to take? So from here I will take, and I am not talking about those. Okay. What are the 4 terms? A minus 3D, A minus D, A plus D, A plus 3D. Okay. 4 terms means like this. So observe here, if you add, what happens? Minus D plus D cancels. Minus 3D plus 3D will be cancelled. Okay, like this you need to think and take the terms carefully. Suppose if 6 terms, how can I take 6 terms? 6 terms, I cannot take this A again. It won't come middle. So same manner how I have taken for 4, like that only I am going to take. I skip this A minus 4D and A plus 4D will be skipped here. So what are the terms I am going to take? So from here I will take A minus 5D, A minus 3D, A minus D, A plus D, A plus 3D, A plus 5D. Okay, like this, if 6 terms given, like this you take. Okay, like this, if any 3 terms, any 4 terms of an AP or any 5 terms of an AP, any question occurred, you need to select the terms in this manner. Okay, is this clear? Suppose any statement there. 5th term is, 5th term means A5. is equal to 2 more. When the word comes 2 more, more means add 2. 2 more than 3 times the fourth term. 3 times the fourth term. When any problem in this manner, if you have, try to understand the question carefully. Okay? Fifth term is 2 more than 3 times fourth term. Like this, you need to split the question and you need to frame the equation. So for next session, you should be perfect with what is the arithmetic progression, sequence, series, what is the first term, what is the last term, and what is the common difference, and sum of n terms when first term and last term is given, sum of n terms when last term is not given. So these are all the formulas which are very important to deal with arithmetic progression. So these all formulas are very important. Try to write these all formulas at least for 10 times today. Okay. So for next session, these are all very important. We are going to meet in our next session with your first exercise of this chapter. Until that, keep watching. Thank you all.